Hello and welcome to our introductory R programming course. I'm statistics professor Joe Guinness, and these videos will help you learn the fundamentals of programming in R. We will start at 0, meaning we won't assume any previous knowledge in R or in programming of any sort, and we'll build everything up to give you the essentials that you need to get started as an R programmer. We'll cover things like getting started with R and RStudio in your first session, which is the topic of this video. We'll cover the basic R data structures, we'll cover writing your own functions, and we'll cover things like making graphics in R. We'll also cover some programming topics such as how to write a for loop and how to do conditional statements like if and else. This is a 7-module course. Each video is roughly an hour. This first one is actually a bit longer because we're going to go pretty slow and not really assume that you know anything. So we'll do things like how to assign a variable and things like that, and how to set up your RStudio, different keyboard shortcuts, so on and so forth. So this is not a Learn R in 30 minutes course. It's a Learn R in 7 weeks. It's part of a real college course for R programming, and we're going to get into the nitty-gritty a little bit. So if you have the time and the patience, this is the right course for you if you've never programmed in R or potentially in any language before. So let's get started. I hope you enjoy it. The first thing you'll need to do is install the necessary software for the course. That involves installing 2 things, R and RStudio. R is the programming language and the program that you'll be running your commands in to analyze data. The second is RStudio. RStudio is what's called an integrated development environment. That's the program we'll be interacting with most. We'll be editing code in there. We'll be sending code to the R program to test it out and see how it runs. The only really necessary part is installing R, but RStudio has a lot of really nice features that help you as a programmer. So go ahead and install both of them. So to install R, you'll click Download and Install R. We're on the Posit website. Posit is the company that manages RStudio, and they have a link to install R. So you click Download and Install R. That will take you to a website called CRAN. CRAN is the official place for R, for installing the program and all the packages that you'll need in R. And if you just go to this page, there are links for your particular system, so just select the right one, navigate to your page, and follow the instructions. Then you'll go and install RStudio, and you'll do that right here on the Posit page. So just scroll down here, find the links for your system, and go ahead and install it, and then you'll be good to go. Once you have those things installed, you can fire up RStudio, and it should look something like this. It's organized around these 4 panes. So right now it's set up so there's a pane where there's just a plain text file up here. Below, down here, this is where R is running, so the R program is running. We call that the R console, so it prints out some information here about your version of R. Yours may be slightly different from mine. It's perfectly fine. As long as it's over 4.0, it should be fine for this. And here there's like a little terminal. We call it the console, where you can type in commands. So like print hello, and it will print hello. Up on the top right, there's another panel. This has things like variables you've stored. We'll cover this later. And then the bottom right is this panel. So this has, yours will look different because you have different files on your computer. But you'll be looking at your files here, any plots you have, packages you've installed, so on and so forth. Okay, so let's open up our file here. So let's open this one. And we're going to split this up into 2 parts. We're in the first part now because we've installed R, we've installed RStudio. So I'll have a link in the description to this file. So what you'll want to do is download this file and put it on your computer. And you want to be careful about how you organize your files. So let me show you what I've done here. So I've created, here's my home folder. Inside of that, I put everything in Dropbox. And then within that, I have a folder called Teaching. And since we're going to be using something called GitHub for this, I created a folder inside that called Repos. And then the folder where all the material for this course is going to go is a folder called Intro R. So this is really important. If you're in the habit of just downloading everything into the downloads folder, try to get out of that habit. Try to organize your files in a way that allows you to find them easily and make sense of what is what. So in this folder, Intro R, basically have two folders inside of it. One's datasets. We're going to be working with this dataset later on. And I have a folder called video code. And you'll have access to these files. So organize your folders however you like. It might make sense to, in your home folder, make a folder called Intro R and organize it the same way as mine. That's perfectly fine. But try to get it organized in a way that makes sense to you. And for this one, I think it really makes sense to have a folder called datasets and a folder called video code, and to put the dataset, and I'll give you a link to that in just a minute, here in this folder, because the code we're going to do today will rely on that structure for your folders. Okay, so that's a long story of organize your files nicely. It'll make your life a lot easier. All right, so we've talked about the layout of RStudio, and now we want to talk about configuring some options. So if you go into Tools and you go into Global Options, I'm just going to take you through some of these options. General, there are some things I want you to change. So make sure that this box is unchecked, restore.rdata into workspace at startup. And make sure this thing, save workspace to RData on exit, is set to never. By default, it's not set to those things. I think this is checked, and this is set to either ask or always. And basically what it's doing is if you're working on a project in R, you're working on some code, you have a bunch of variables saved, what it does by default is when you close R, it will save those, and so that next time you open it up, they'll have them available to you. Now that's a bad idea for lots of reasons. One is you want to kind of have a clean slate every time you open R, and you want your code to do only what it does in the code that's listed there. And you don't want to be accidentally or unknowingly loading variables into your workspace. So those should be set to unchecked and never. Let's see, I don't know what the default is here, but this is what I have them set to. Yeah, this is related to, the history is related to commands that you've run previously. So you can leave that however you like, and you can mess around with it. Code, so this is going to be settings for the text files that your code will go into. I think we can leave these. The one thing, if you're kind of an advanced programmer and you like to use Vim key bindings or Emacs key bindings. Personally, I use Vim, but I won't for these videos because I think it's going to be too distracting. So I just set it to default, but if you're a Vim or Emacs user and you prefer that, you could use it. Let's see, that's all we need there. The console, I don't think there's anything to change here. You can leave this as it is. Appearance, so you can play with this. It's kind of fun to play with. You can change, so for one, I have my zoom set to 125%. That's just so the stuff looks bigger on the screen. You will probably have that set to 100, and that should be fine. You can change the font, but that probably don't want to do that. Again, I have these larger, these font size larger. You may want to make them smaller. And then if you want, you can play around with the different themes. If you like a dark theme, you can do that, or pick the one you like. I have it set to Chrome. It seems like a nice one. Let's see. Okay, now here's a big one. So for pane layout, what I want you to do is I want you to have source code. So this is where your code is going to go. So these 4 panels represent the 4 panes. Right now the source is up here, console's here, environment history and connections are up here, and then plots are down here. So what I want you to do is swap these two. So I'm going to go up here and click console, and that will automatically put the environment down here. And I'll show you what happens there. Apply, okay. And then you can change the size of the panes by moving this thing here. You can also minimize them with that. And you could do this. So this is how I like to do my programming in R. I like to have maximal amount of space for the console and for the script. If I need to look at files, I just click this and it comes up and I can move it around. And I almost never interact with this pane down here, so I almost always keep this minimized. The reason behind this is you want to have kind of a full view of your code, and when you print stuff out to the console, you want to have as much space as possible for that as well. You may want to put the console on the left, the code on the right. That's up to you. I like code on the left, console on the right, but I think it's best to have a maximum amount of space for these two, which means you can't have them on the same side. All right, now we're all set up. Next thing I want to do is show you some tips for how to get the most out of these videos in this course. So the first thing is, if it's possible, I would like you to get 2 screens. So one screen will be for watching the video. So that could be an iPad or phone, or even better, a television screen that you can get the videos on. And then another screen that's just your laptop that's just going to be running RStudio. So it's going to look just like this. And as you're watching the video on your laptop, I want you to open up RStudio and open up the file that's called _ comments.r. So for this one, it'll be called first session comments.r. And it'll be just the comments and no code in it. And as you're watching the video, I want you to be typing in the commands with me as I type them in and running them in the console. That way you're going to get practice, get muscle memory typing things in. You're going to be putting arguments into functions, and you're going to just be doing it, which is the best way to learn something. The other benefit of that is, as you're watching the video, you're going to have questions like, what would happen if I had done this instead of what he did in the video? And you can just pause the video and test things out as you go. That'll be a really fast way to explore your knowledge of R and to learn new things as you go. The other thing is, when we look at help files, it really will be a bit slow, but just read the help files as long as they're not too long. You may be reading things that are not immediately relevant to you, but if you get in the habit of reading them, that'll make things go faster down the line, because you'll remember something you read a while ago, and it'll come back to you as you're trying to do something. So at the beginning, take the time and read the help files, get familiar with them, and as you progress, you'll be able to do that faster and be able to just grab the information you need. And this way of doing things, I just have a note here. This is going to feel a bit slow at first, but doing things in this way where you're typing in the commands, you're running them, you're doing a little bit of self-exploration, you're doing a little bit of reading. Ultimately, this is going to be a faster path to mastering the material, as opposed to just kind of Googling things and learning what you need to learn for the current task at hand. This is going to feel a bit slower at first, but you're going to master things more quickly doing it this way. So try to keep these tips in mind, and just, you're going to have to trust me on this one, but try to do it this way, and I think you'll learn more and you'll learn faster. What I have open here is what's called an R script. These are files that end in .r, so this is called first session code.r. This is just a regular plain text file that you can open in any text editor. And here I have it open in RStudio. And you can just type things into here. So print hello. And you can see this turns red to see that there are unsaved changes. So if I do Control S, that will save it. You can also click the Save button, which I think is this one here, but I never click that. I always use the keyboard shortcut. And you should learn these keyboard shortcuts. So we're going to go through some of them in a minute here. So all I've done here is I have edited this text file, this R script, but nothing has happened over here in the console. So what I need to do to make things happen in the console is I'll put my cursor on the line that I want to run. And then on my system, I do Control Enter, and this will send the line from the script over to the console. So Control Enter sends it over here, and it prints hello. Okay, so now we have two keyboard shortcuts. Control S. Again, on your system, if it's a Mac, it's probably Command S. And I think on Windows, it's Control S. And then the second keyboard shortcut on my system is Control Enter. And on Mac, again, it could be Command Enter to send a line over to the console. Now, to see what the keyboard shortcuts are on your computer, you'll click on the Tools menu and then click Keyboard Shortcuts Help. You can also get there by doing Alt-Shift-K, but again, that may be different on your computer. So this will show you all the shortcuts for your computer. And there are a lot of them. So I don't want you to go through and try to memorize all these. But what you should probably do is periodically, as you're learning more and more R, go through and take a look at these. And probably each time you'll go through, you'll see something new that you didn't know about that's going to make your life easier. So what we've seen so far is Control Enter, run selected lines. If you're on a Mac, it'll probably say Command Enter. We've seen Control S to save, and then there's other things like Control O to open, and of course, all kinds of other things. The one I want to show you now is moving between panes. So these are ones that will make you a little bit more efficient. So there's commands Control 1 and Control 2 to switch between the source code, the R script, and between the console. So a lot of times you'll be typing something in the source code and you'll want to just switch over to the console and type something into the console and run it without editing the source file. So on my system, that's Control 1 and Control 2. On yours, it may be different. So just click out of here and then test that one out. So you could do Control 2 on mine, go over there. Now the cursor's over here, and then Control 1 to go back. All right, so just to review, Control Enter runs the line. I can edit this. Control Save to save. You don't have to save it before you run the line, but I could do this. Another one that's useful is Shift up or down will highlight the whole line. So there may be situations where you want to run multiple lines at the same time. If you want to run multiple lines at the same time, just highlight them and Control Enter. Here, nothing extra happens because there's nothing on this line, but we could add something. And this will run both of them. This line is a comment. It starts with a hashtag or pound sign. And so this is just to include text in your R script, which is not code. So if you do Control Enter on this, nothing happens in the console, aside from sending the comment over. But there's nothing that gets evaluated here. The next thing you need to understand is how your working directory works. So when you're working in R, you are in a folder, also known as a directory, and different commands will behave differently depending on which folder you're in. So to find out which folder you're in, you'll do getWD. GetWD is a function, so you're going to use parentheses or round brackets to run it. So getWD and then Control Enter to get over there. So I am in my what's called my home directory, home Joe. And what I want to do is I want to get to the directory that has the files. Because a good practice is to be in the directory that contains the file that you're working on. So I'm in first session code. On my computer, I've saved that in this sequence of folders. So here's my home directory. This is home Joe. Inside of that, I have a folder called Dropbox. Inside of that, I have a folder called Teaching. Inside of that is repos, because this is going to be a GitHub repository. And then there's a folder called Intro R, which has the files for this course. And inside of that, there's a folder called Video Code. So this may seem complicated, but what you really need to do is get in the habit of organizing files on your computer in a way that makes it easier for you to make sense of them and find them quickly. So I made a folder called Intro R and then a folder called Video Code, which contains first session code.r. That's the file we're working on. And I want to get to this video code thing. So what I'll type here is setwd. And to get there, I'm going to use what's called the global path. So the global path starts with a slash. So home, let's see, home, Joe, Dropbox, teaching, and I'm just following this sequence here. Repos, intro R, video code. So what's going to happen when I run setwd, set working directory, it's going to change my working directory to this folder. And then I'll run getwd again. Now it shows that I'm in that folder. Now if I want to move around relative to this particular folder, video code, I can use what's called local or relative paths. So global versus local or relative paths. So if I want to go back up into intro R, which is going left one, I'll do setwd double dot. Double dot is the special set of characters to go up a directory. And I'll do getwd. Now I'm in intro R instead of video code. If I want to go into the datasets directory, so I want to move relative to where I am now. So I'll just type datasets directly. And note that I'm not starting this with a slash. So when you're working with local or relative paths, you won't start with a slash. Global paths will start with a slash. So this will go down into datasets and getwd again. See, now I'm in datasets. And then I can combine these things. So I can say setwd. If I want to go back into video code, I'll go up into intro R slash down into datasets. Oh, sorry, down into video code. So I'm doing two steps in one. If I run that and then getwd again, now I'm back in video code. So a few concepts to review here. One is just the concept of directories in general. You want to be saving files on your computer in this sequence of folders or directories, one inside of the other, in a hierarchy that makes sense for you. You don't have to do it exactly the same way I do. And then global paths, you specify the whole sequence to get to where you want to be. And then local paths are specified relative, and there's a special set of characters, double dot, that goes up one directory. I don't know why it's called up and down versus, it seems like it should be called left and right, because left goes back to intro R, right goes into datasets, but that's the terminology that people use. All right, now we're prepared to read some data into R. And that data set is, so I'm going to go back up into intro R. And in the datasets directory, there's a few things in here. There's one called Titanic5.csv. So if I click that here, I can click View File. That will open it up as a text file in my source pane. And I'm just dragging this to make it bigger. So this is called a CSV for comma separated values. And each row corresponds to an observation, and in this particular case, each row is a passenger on the Titanic ship. The first row is different. The first row is the names of all the different variables. So the first row says name ID, comma, name, sex, name, comma, sex, comma, age, comma, class. So these are listing out all the different variables that are reported for each of the passengers on the Titanic. So in this first row, the name ID for the first person is 28. The name is Alan, comma, Miss Elizabeth Walton, close quote, comma, sex is female, comma, age is 29, so on and so forth. So within each row, each variable is separated by a comma. That's why it's called comma separated format. Okay, so let's make this smaller, and let's go back to our script. And the function for reading in a CSV file in R is called read.csv. But so let's try this. Let's say Titanic, it's called Titanic5.csv. So see if you can predict what's going to happen here. It's going to say error, cannot open the connection. It's a very common error that people get. Cannot find the file Titanic5.csv, no such file or directory. So you can probably guess, if you're a pro, you can probably guess what the problem is, but the problem is that in our current directory, there is no file called Titanic5.csv. So you can see that we're using local or relative paths here because we're not starting with a slash. So the problem is that we're in video code, and there's no file in here called Titanic5.csv because it's in the datasets directory. So to see which files are in the current directory that you're in, you can use list.files, Control Enter, send it over. These are some of the files that are in the directory. To see what's in a different directory, you can use relative path. So as the argument, I can put /datasets, run that. That will show me that there is a file called Titanic5.csv in the datasets directory. So to read in that file, I'm going to use read.csv, but I'm going to give the relative path to that file, which is up into intro R / down into datasets / the file name Titanic5.csv. So if I do Control Enter on that, I should get the data set right here. So here's the data set read into R. You can see now it's organized a little bit better than the raw text file. They're kind of lined up in the columns to make it easier to read. And it prints out some of the data, but I think at the end it says reached max, get option max.print, omitted 1257 rows. So all that means is that it wanted to print the whole thing, but it decided that would take up way too much space, so it didn't print them all. That's fine. Now what we're going to be doing is doing stuff with the data, like calculating statistics and things like that. And we don't want to have to keep running this over and over. So what we're going to do is we're going to assign the output of read.csv to an object. So Titanic is read.csv. Oh, by the way, so if I do, as I'm typing this in, you may have seen some like options come up. So if I hit tab from here, it'll give me a list of possible completions. So if I have it on data sets, I can just hit enter and it will complete. And I can type Tita, and another thing I could do is hit tab and it'll give me some options. I just scroll down to Titanic5.csv, hit enter, close. So get used to tab, what's called tab completion. So if you type out part of the file name or folder name and hit tab, it will often complete it for you. That can make things a lot faster as well. Okay, so I need to run this line. Oh, I already ran that line with Control Enter. And now if I type in Titanic, that's the whole thing. Now that's a bit overwhelming because it's like many lines printed at the same time. So if you want to just print the first 6 lines, you can type head Titanic. And here I put a space here. Spaces don't really matter in R unless you're separating different words. So this is the exact same thing as doing this. I like to put spaces sometimes if I had room because it makes things easier to read. So this will just print the first 6 rows here, and that makes it a little bit easier to see all the variables that are available. Another common thing you'll be using is, let's see, class Titanic. It's a data frame. So data frame is the object, and we'll get more into objects in the next module, for storing what's called tabular data that can come in tables. All right, so yeah, just to review here, CSV is for storing tabular data. Data frame is the R object for storing tabular data. CSV is the text file format. Each of the rows an observation. In this case, it's one person, one passenger on the Titanic. And each column we refer to as a variable. So associated with this person, they have a sex, an age, a ticket number, where they join, whether they survive, so on and so forth. And what's kind of useful, one thing that's really useful is the different columns can have different types. So name ID is a number, age is a number, whereas sex is what's called a character. So it's letters and numbers combined. And if we want to get more information about a data frame, there's several functions that can help that. One of the first ones you'll probably be using is dim. This tells us how many rows and columns are in the data, or equivalently how many observations and variables. So there's 1,309 rows for 19 variables. We can also get that information with the nRow function and the ncol function if you just need the number of rows or the number of columns. A useful one this is usually the first one I use for data frames is str. That prints out information about each row, and it's a little bit more informative information. So it says, when I do str Titanic, it says it's a data frame, 1,309 observations of 19 variables. And then it lists out all the different variables along with the first few values for each of them. So name ID is an int type for integer. Those are the first few name IDs. Name is CHR for character, and these are the first few names. Sex, character, age is numeric, that's differentiating from integer. We'll get more into that into the next lecture. But that just means it's not an integer. It could have a decimal associated with it. And then it lists out all the other ones. So str is often a good first one to look at to see what's in there. You can also do, if you want to get the column names, you could do names Titanic. And that is also accessed with call names. And this stuff should be down here to be consistent with my comments. Okay, so one of the ones was, let's see, ticket got coded as a character. So if we want to figure out, so it looks like they're numbers, but it actually got coded as a character. So let's investigate what happened here. So we'll want to grab, there's a few ways to do this. So if I want to look at the ticket column alone, there's several ways to do it, and we'll go through all of them. But I'll do $, and tab will bring up the other ones, or I could just type in ticket, and it will print them out. So if you stare at these, I think we'll find one. Here we go. Some of the values are actually not raw numbers. They have letters associated with them. So what R does is it says, well, I don't know how to convert this sequence of characters to a number, so I'm going to store the whole thing as characters. This is your first example of what's called automatic conversion from numbers to characters in R. So it decided that ticket should be a character because it doesn't know how to convert this to just a raw number. The other thing that's kind of interesting is if you look at the data, so let's just look at the first row, the name has a comma in it. So what's happening here? So how does it know that this comma is not the separator between the name and the sex category? It doesn't know that this is not a sex. The way it figured that out is that whoever created this data set put the name in quotes. So that's telling R that this comma is ending the name ID variable, and then everything in here, it's going to kind of ignore the content when looking for commas. It's just going to go to the next quote, and now it knows if there's a comma there that we're starting a new variable. So even though this variable has a comma in it, because it was saved with quotes, it knows that this comma is not a separator. It's just part of the name. So it is possible to include character variables that have commas as long as you put them in quotes in your CSV. You'll be spending a lot of time accessing different information from data frames in R. So I just want to go through quickly how to do that. So you've already seen how to access a column. So if I want to get the age column, I'll do $age, and there's auto completions here. So, and then Control Enter will send it over. So you may want to do something with that or assign that to a new variable. But one way to get it is $ with the name of the variable. You can also do Titanic square bracket, comma, age. So what's happening here is I'm treating this like a table with rows and with columns. And what goes before the comma is which rows I want to access. I'm leaving that blank, which tells R that I want all the rows. And then what goes after the comma is which column I want to access. So I'm telling it I want to access the age column. So this will do the exact same thing. You can also get a few rows. So say you want the first 10 rows. I can say 1 to 10 age. That gets the first 10 values of age. And I can also do it directly here, 1 to 10. Okay, so let's look at what we're actually working with here, because this is getting printed out a bit different than the data frame was. So if I say class Titanic $age for the age column, this says numeric. Importantly, it doesn't say data frame. So when I pull out a column from the data frame, it's storing it in what's called a vector. And the printing is a bit different, but each vector has a type of variable. In this case, it's numeric. And of course, the same thing, Titanic age here will be numeric. Now you can pull out, just like I pulled out multiple rows here, I can pull out multiple columns. So I could do Titanic, let's just get the first 10 rows, but I'm going to get age and survived. All right, so to get multiple rows, well, let me show you the wrong way first. You might think you'd do something like this, but this, you can see how this could be confusing. Am I accessing something that has like 3 dimensions to it, and in the second dimension I'm getting age, the third I'm getting survived, or am I accessing 2 columns? So what we need to do is put these together to say that they're two columns, age and survived. The function for doing that is called C. C stands for concatenate. It's for putting things together. So for example, if I were just to run C age survived, that returns a single object with two elements, age and survived. So this will grab those two columns. And of course, I'm just grabbing the first 10 rows, so it's a small data frame. But it is a data frame. So if I say class Titanic 110 age survived, it will say data frame. And of course, you could do things like, if I didn't want to type 1 to 10, I could do head of the whole thing. This is just going to return the first 6 rows. And if I wanted 10, you can actually give head a second argument, n equals 10. So this is an equivalent way of doing the same thing as up here. And this is going to be a theme. So in programming and R programming in general and in R program, there's often many ways to do the same thing. And this is just one example of that. Just like you accessed rows with the row number, you can also access columns with the column number. So if I say names Titanic, I can see that the age column is the 4th one. So I'm just counting from 1. So 1, 2, 3, 4. And survived is the 12th one. So job is the 11th and survived is the 12th. By the way, R will print out vectors in this way. So it prints out the index or the position that it's printing. So this 1 corresponds to it's the first one, which is name ID. And then it lists them out left to right. And then when it wraps around, it tells you which one you're looking at. So ticket is the 6th one. Job is the 11th. Age F code is the 16th. So age is the 4th one. And survived is the 12th column. So I can also say Titanic. Let's just get the first 10. Concatenate 4 and 12. Close square bracket, Control Enter. That will do the same thing. So you can access columns with either the name of the column or with the number of the column. Now, one of the main things you'll be doing in R is calculating statistics and running models. So you can calculate all kinds of statistics associated with the different columns. For example, you can say mean. If I want to get the average age, I'll say Titanic $age. And Control Enter will run that. And I get a NA. The reason is that some of the ages are missing. Let's see if we can see them. Yeah, some of the ages are not available for whatever reason. And when the age is not available, it uses this code NA. So NA indicates a missing value. So whenever there's a variable that is corrupted by missing values, if you try to take the mean, it'll say the mean is NA. So if you want to do the mean after removing the missing values, you say Titanic $age NA.rm equals true. So the average age is 29.5151. You can also do, all kinds of different things. Standard deviation. Uh, 13.85. You can get the max. You could do the min. So I'm just copy and pasting to make it go faster. You can do, useful one is range. So that gives the minimum and the maximum. And then there's a really useful one called summary. And here you don't include na.rm equals true because it tells you at the end how many missing values there are. So this says the minimum, first quartile, median, mean, third quartile, max, and number of missing values. So these are just a few ways to get some basic statistics, and you can apply this to other columns as well. Another one, well, let's just do a few more. You can plot things. So if I want to get a histogram of the ages, I do this. This will pop up in the bottom right panel if you have it organized the same way as me. And this is a histogram of the ages. Let's see, you can do, oh, this is a good one. Table, Titanic dollar survived. So what table will do is it'll print out, it's sort of like a histogram, but it's printing out the number of times each value appears in the data. So remember, survived, these are either 0 or 1. So 0 is not survived, 1 is survived. So what table is going to do is it's going to count up the zeros and count up the ones. Oh, I don't know what that is. There are 809 that did not survive and 500 that did survive. And then, of course, you can do all kinds of different plots. So I'm just going to plot Titanic dollar age and Titanic dollar survive. So what this will do is it'll make a scatter plot with the ages on the horizontal axis, and then I'll do comma, and then on the vertical axis I want whether or not they survived. Oh, and I made it too small, so okay. That's why I got that error above, because I had made it small but hadn't completely minimized it. All right. So these are ages on the horizontal, whether or not they survive. So what we're going to do later, we're going to come back to this plot and try to improve it. You can also use R like a calculator. We've done a few calculations up here, but you can do things like, I don't know, 3 plus 7 is 10. You could do square root of 26 is something a little bigger than 5. You can do logarithms, so log of that is that. And then there's all kinds of other mathematical operations you can do. And then, so these are kind of mathematical operations on numbers, but you can also apply them to vectors. So to see how this works, let's make a vector called age 10. And it's going to be the age column, but I'm going to take the first 10 entries. Oh, by the way, what's going on here? So 1:10 means I want to get all the integers between 1 and 10. So if I do 1:10, that's that. It's equivalent to doing this. In R. Okay, so that's grabbing, age 10 is grabbing the first, oh, see that? It's giving me a recommendation. So age 10. So if I just hit tab, it'll complete that. All right, so those are the first 10 ages. And I can do things like, we saw this above, but the minimum of the first 10 is 0.92. We can add things to it. So this is kind of interesting. Age 10 plus 1. So age 10 is a vector with 10 entries. And when I do plus 1, it's going to add 1 to each of the ages. So let me make this smaller. So the first one was 29, but when I add 1, it's 30. 0.92 becomes 1.92. I can multiply, so age 10 times 2. I can round, so round age 10 will round the ages to the nearest integer. So the only one that changed here is 0.92 became 1. Otherwise, it's the same. And I could do something like this. Okay, so age 10 minus round age 10. So this part is this over here. This part is this up here. And so you can see this operation is a bit different from this one. This one, we took the number 1 and we added it to each of the ages. Here, we're subtracting a length 10 vector from a different length 10 vector. So what it's going to do is going to subtract off the first. So it's going to take the first element of this one minus the first element of this one, second element of this one minus the second element of that one, so on and so forth. So if we do this, most of these are 0 because the ages were already rounded. The only one that's non-zero is the one that was 0.92. It rounded to 1. If I do 0.92 minus 1, I get minus 0.08. Okay, so these are some basic operations. There's obviously many more you could do, sines and cosines, all that kind of stuff. And they can operate on full vectors or individual numbers. Now, we've already looked at a bunch of different functions in R. Round, plot, hist, range, so on and so forth. And we're really only scratching the surface. And there's no way you're going to be able to memorize how to use each function. So R provides what's called documentation for each function. And the way you access the documentation for a function is question mark and then the name of the function that you want to look up. So if we want to look at the round one, first of all, it gives a little pop-up here. So this is a snippet of information about the round function. And this comes from the documentation file. But if you want to look at the full documentation file, you do Control-Enter on that to send it over. It will pop up this panel with the Help tab. And I'm going to maximize this. And this is what a typical documentation file looks like. It says R documentation, talks about this file is about rounding of numbers, and it actually documents a few different functions: ceiling, floor, trunk, round, and signif. So there's a description. It's like a plain English description of what the functions are doing. So for round rounds the values in its first argument to the specified number of decimal places, where the default is 0. See details about round to even when rounding off a 5. And then there's going to be another section called usage. That's how to call the function. So it'll show you, how to call the function with the different arguments. And then below that, it'll have a section called arguments, which tells you what each of the arguments is. So the first argument here, it's calling x. And this is a numeric vector. We put in age 10. And then there's a second argument after the comma called digits. And the second argument is different than the first because it has a default value. So that's this default value is referring to here of 0. So x, the first argument, does not have a default value. That's the vector you're rounding. Makes sense because if you're rounding, you want to give it something to round. So it doesn't know what to do if you don't give it anything. And then by default, it rounds to 0 digits, means it rounds to an integer. But you can change this argument to something else, and we'll use that in a second. There's also usually a section called details with more details about the function, I guess, for lack of a better term. And then there's other kind of optional sections. Let's see. There's usually one called value. This one doesn't have one called value. Value tells you what the function returns, and this one doesn't have one. And then often there'll be a section called examples at the end, which has some real examples that you can copy and paste and run yourself. Okay, so let's use this. So it says digits is the integer indicating the number of decimal places or significant digits to be used. Negative values are allowed. Okay. Let's close this, or minimize it, not close it. So if we want to, I don't know, let's say round we'll set the first argument x to age 10 and digits equal to 1 to round it to 1 digit. Okay, so of course these ones don't get changed because they were already integers, but this was originally 0.92 and it got rounded to 0.9 instead of 1 because we're rounding it to 1 digit. You can also just say round age 10 1. So here I'm just putting them in the same order that they appeared in the documentation. X is the thing we want to round. And then digits, we're not saying digits equal 1, but if I just put 1, it knows that you want to assign 1 to the digits argument. So this will work as well, gives the same thing. Okay, now in this first one, it looks like we're making an assignment. Age 10 is assigned to X. Remember, you can use either the assignment operator. So the assignment operator is up here. Here. So less than followed by a hyphen is how you do an assignment. So what's happening here is this thing is getting assigned to this variable. You can also do it with equals. This works just as well. And but generally people prefer to use this in R even though they do the same thing. The reason is because the equal sign is used for assigning values to arguments. So what actually happens here, if I run this, it's not actually assigning age 10 to X in my workspace here. So if I type X, nothing's there. Object X not found. If I type digits, nothing is there. If I want to see all of the different variables that have values assigned to them, I do ls is a function I can call. And you can see there's age 10 and Titanic. You can also see it here. If I make this bigger, the environment tab says I have a data frame called Titanic and I have a vector called age 10. Okay, so there's a few ways to see it, but the important point I want to make here is this is not actually an assignment when it's passed as an argument to a function. If I want to make that assignment, I have to do x less than hyphen, let's say 4. Now it's available. And now if I do ls, x is there. It appears in my environment. And you can also remove things from your environment. Remove x will get rid of it. And now if I do ls, it's gone. And it's disappeared from here as well. Now I've been typing things like ls over here in the script and sending them over with Control Enter. But I can also just, if it's not a piece of code that I actually want to save, say I'm just kind of exploring my workspace or the Titanic, and I want to just look at things in the console, I don't have to actually type them into the script and send them over. I can type them directly into the console. So I do Control 2, I get over to the console, I can say like head Titanic, and that will run it here. So typically you only put stuff in the script that you want to save for further use. I'm putting almost everything in here because I want to save them for you, but you can also, you'll also be just typing things directly in here like ls. Okay. I want to do a little bit of a lesson on creating your own vectors. We'll have a full lecture on this, so this is just a bit of a preview. One of the things we've seen so far is the colon operator, so 1 colon 10. We'll do all the numbers between 1 and 10. You can start anywhere, so 5 to 8. We'll do those. We've seen the concatenate function, so this will just put stuff together. So that'll make a vector of length 3, 7, 9, 10. You can also concatenate, we've seen this with the column names, you can concatenate characters. So let's just do this just to show you something kind of cool about RStudio. If you type in recognized color, RStudio will actually color it with the color. So this is a good way to just preview some of the different colors. Goldenrod is one that has different values. Okay. So that's characters, numerics. Another function you'll be using often is the seek function to create a sequence of numbers. So if I want to make a sequence of numbers between 0 and 1 separated by about a third, I'll do that. So this is a sequence starting at 0, ending at 1, separated by this amount. So you can see what it does is it starts 0, does the next value by, does another by and another by. And then it knows that if it did another by 0.333, it would exceed 1, and so it stops there. You can see this maybe more clearly. There, same thing. It knows that the next one would be 1.2, which exceeds 1, so it stops there. If you want to get the documentation, you do $seek. That pulls it up here. And you can see there's different arguments. So the first one's from, second one's to. We use 0 and 1. We use the by. So by has a default argument, but it is in terms of another argument called length.out. So what happens if I say seek 0, 10? Okay, that just does integer. So that's probably documented somewhere here. If I wanted to find that, I'll look at length.out, and the default value is null. So somewhere in here, it's going to tell us, hopefully if it's good documentation, that when it's set to null, it just does separated by 1. Okay. So we do know that we can use, instead of using by, we can use length.out, because if we specify length.out, it will set the by. What length.out does, it's the desired length of the sequence. So if I were to do seq01 length.out equals 4, this is going to do probably what I actually wanted, which is a sequence of numbers that starts at 0, ends at 1, but is separated by a third, and then we get this here. Okay, so seek is one function you'll be using. There's different ways to do it, either with by or length.out. Another one that's really commonly used is rep. So rep replicates the values in X. Let's just use it. This is of course all documented, but we can say rep 0.5 3 times. So it repeats the number 0.5 3 times. You can even give a vector as the first argument. So here I'm setting the first argument to the vector 0, 1. I can repeat that 3 times. And it just does 0, 1, 0, 1, 0, 1. You can also say each equals 3. So what that will do is it's going to take each of these, repeat them 3 times, and then, so repeat 0 3 times and then 1 3 times. So it does that. This is a very useful function. Let's see. This is just showing how you could do this with by assigning something. So I'm assigning 0, 1 to x. That does, oops, I didn't run that because x is not found. That does the same thing. Often in R, since you're doing statistics, you'll be working with random numbers. So there's a whole bunch of distributions that are pre-coded into R. If you want to simulate from those distributions, usually the function starts with R, lowercase r, and then the distribution name. So RUnif is one of them. And if I say 10, this will give me 10 uniform numbers between 0 and 1. If I want to know for sure, I'll do help file for RUnif. Pulls this up. And n is a required argument, the number we want to simulate. And then it has default values for the other arguments. So the default value for the lower bound of the uniform distribution is 0, and the default value for the upper bound is 1. Of course, we could change that. You could say RUnif 10, 0, 5. So this would be numbers between 0 and 5. And then each of these distributions has other functions. Usually there's 4 functions. So D is the density. P is the CDF. Q is the quantile function. And then the R version of each one is to simulate. So there's also R norm. Same thing. This has 4 things. And the arguments will differ because uniform is specified by its boundaries, normal is specified by its mean and standard deviation. Okay, so that's how you simulate. If you want to just be convinced, let's just simulate 10,000 and we'll make a histogram. So those are roughly uniform. If I want to really look uniform, I'll do a whole bunch of them. And then we could do normals as well. That's a nice looking normal distribution. By the way, hist has an argument called breaks. You can either specify directly what the breakpoint should be in the histogram, or you can just give it a number to say how many breakpoints you want. So maybe I want 200 breakpoints. And now we get a nice, beautiful, smooth looking histogram. All right, so now let's do something useful. Let's use what we've learned to improve our plot of survive versus age. So just to remind us, Titanic $age, Titanic $survived. So this is the plot we showed earlier. The problem with this plot is that since the ages are reported as integers, they're pretty much, a lot of them are on top of each other. So this point here actually represents many different people. And there's no way of knowing, except by kind of seeing that these are a little bit thicker. There's no way of knowing how many people here who died at age 20. So, and then the same thing for this variable. It's either 0 or 1, which makes them be on top of each other. So one way of dealing with that is you can add a little bit of noise or a little what's called jitter to the points to kind of spread them out a little bit to make it easier to at least have an eyeball estimate of how many people are in each group. So we're going to use uniform noise to do this. So we've already looked at the documentation for RUnif. So let's, this is going to help us. We're going to define an intermediate variable called n, which is n-row Titanic. Reminder, this is 1309. And then let's define a variable called x. And x is going to be Titanic $age, but we're going to add some noise to it. So I'm going to add RUnif n of them. So I want to move these left and right. So let's do min equals minus 0.2, max equals minus 0.2. So these are separated by 1 here. So I'm going to move some of them to the left, some to the right, but not too much. And then y is going to be Titanic $survive plus RUnif. We'll do n of them again. Let's make this a little bit tighter. Okay, so let's run this, run this, run this. And then we'll just plot x against, or y against x. And you can see here what the result is. So these got moved a little bit left to right, not very much. And then they got moved, relative to the size of the axis, more in the vertical, even though this is smaller. So now you can see a lot better that there actually are very few people in general in this age group. If you remember from the histogram, that's what the histogram showed as well. There are a lot in this age group. And if you look at, you can kind of guess like the proportions almost. So in the lowest age group, actually a higher proportion survive. They're more kind of up here than down here. But in these mid and higher age groups, many of the people died. Actually, nobody survived over the age of about 65 or so. Okay, so that shows you a little bit more information in the plot. Of course, there's other ways of doing this. We can add normal noise. We could make a table. We can add a line to show kind of the empirical proportion, but this is just a quick way to visualize the data a little bit better than the default plot. Okay, so we've read data in, we've defined variables, we've calculated statistics, we've made different plots. Now, next thing I want to show you is how to save your data. So let's just look again. Head Titanic. This is the data set. And one thing about the data set, it has this URL thing, and to me that's not so useful because I don't know what that is, and I wouldn't know how to get to here. So if I wanted to kind of save space on my computer, I might save a version of this data set that didn't have the URL. So the first thing I want to show you is how do you remove a column. One way of doing that is to say, well, one way would be to select all the columns except for that one. And this happens to be, if you count them out, this happens to be the 13th column. So you could do like 1, 12, skip 13, and then 14 to end call Titanic. That will do what we want, but that's kind of a mess. The easier way is to just use a minus sign, minus 13. So R, if you give a negative column number, R will interpret that as all columns except for that one. So if I do that, it's the same data set, but it does not have that URL column. Okay, so I want to save that. The function for writing data to a CSV, you might guess, is called write.csv. So write.csv, Titanic. So it's going to write that. The second argument is where I want to save it, and it's called file. So file equals. Now, let's head over to our console real quick and remind us where we are. So we're in video code. We actually want to save it. If we go to the Files tab, we want to save it in datasets. That would be a logical place to save it. So what I'm going to do is I'm going to do double dot goes up, back into datasets, and I'm going to call this Titanic 5. I think I already saved one. Okay, without URL, .csv. And let me just move this slightly. Okay. All right, so this will write this thing with this file name. And let's just do it and see what happens. Files, Titanic5.csv without URL. Okay, you can see that was just saved. View file. And here it is. So this is the data set without the URL code. Now, a couple things to note. One, it puts quotes everywhere where things were characters. So it doesn't quote like the ages. There is a way to remove the quotes, but that is dangerous because you don't want to remove these quotes. So we're not going to do that. The other thing it does is it adds this extra column for row numbers, or sorry, the row numbers, but they're also the row names. That's not too informative because it's just telling us that the first row is called 1. Well, actually, the first row is the names of the columns, and the second row is the first row of data, row 1. So you can actually tell it not to do row numbers. I usually do that, or sorry, not to do row names. So if you do $write.csv to see the documentation. Write.csv is very similar to write.table, so they get documented together. Actually, write.csv is really just write.table, but it sets the separator to comma and may change a couple of other things. But if we don't want the row names, you can see row names are true by default. So we can say write.csv, yada, yada, yada. What I'm doing is I'm making space. So actually, let me go back. So I could just keep typing on here, row.names. There's no limit to how wide it can be. So this piece of code will run fine, but it doesn't look good because it's off the page. So when you get things that run off the page, it's a good idea to reorganize things. And spaces don't really matter in R. So you can put new lines, you could put spaces, as long as you remember to have a comma separating the different arguments and then close your brackets. This will work just fine. So let's do that. And if I look at this file again, you can see it's removed those row names. So this looks, I think, a little bit better because those row names weren't really adding anything. It's still quoting everything that was a character. The argument to remove the quotes is quote. By default, that's true. But setting that to false is dangerous here because of the comma in this one. It's going to mess things up. There is a way to get around that. So quote can be a logical value or a numeric vector. If true, any character or factor columns will be surrounded by double quotes. If a numeric vector, its elements are taken as the indices of columns to quote. In both cases, row and column names are quoted if they are written. Okay, that's actually not that complicated. Let's do that real quick. So if I say quote equals false, this will mess things up. But I can say quote equals, which one was the problem one? The second column. This is just stuff this worked fine. This was stuff about the graphics thing, the plots. Sometimes it gives that warning. And now you can see this is only quoting, and this is a bit more compact. It's only quoting this one. Okay, so that's kind of cool. All right, so that's writing to CSV. If I was actually doing this, I probably wouldn't use so much space. I would probably define an intermediate variable called, maybe call it fname. And then I would use that to get everything onto the same line. So that's that. File equals fname, row.names equals false, quote equals 2. So basically the problematic one that takes up a lot of space is that. So what I can do is just define a variable called fname and then reference it here. So this will do, I have an extra comma. Get rid of that. So that does the same thing. You could see it. Still looks good here. Okay, last thing I want to show you is how to save data in R's proprietary format, which is the RData file type. The function for doing that is called save. And the way you call it is you just list out the R objects that you want to save. So what's going to happen here is we're not writing, an R object to a text file. We're just kind of saving the R object directly. So we can take a data frame, and instead of writing it to CSV, we're just saving it as a data frame. We can load it back in. Okay, so you have to give it the objects that you want to save and a file name. So we want to save, okay, let's try this first. Titanic -13. We want to save the Titanic thing without a URL. The file is going to be datasets, this one here. That gives an error, and it says object Titanic 13 not found. So there is no object named Titanic 13. So what we actually have to do is we have to create an object that we actually want to save. So I'm going to call that Titanic 2. And just to verify that we did the right thing, that's the thing we want to save. Doesn't have the URL. And we'll run this, but instead of this, we'll say Titanic 2. Okay, so this saved a file in datasets. Titanic 5 without URL.RData was just saved. And we have Titanic 2 in the workspace, but if we remove it, let's say remove Titanic 2, it's gone, so it's not there. Now to load in the RData file that you saved, you just do load, and you give the path. Here I'm doing the relative path, data sets, the RData file. That will load it in, and now we have Titanic 2 here, and we can access it by typing head Titanic 2. Okay, so this is saving in R's custom proprietary data type. So that allows you to save actual R objects. This is writing things to a text file, in this case a CSV file. One of the things to know about that, it's just kind of interesting, is usually if you take a data frame and save it as a CSV and save it as an RData file, the RData file will have a smaller file size. Here it's about, well, it's less than a third the size as the text CSV version. That's because R uses something called data compression to make the file size smaller. So often this will happen a lot because of compression. Now the downside is if you want to send the data to someone who's not using R, is using some other, using Excel, for example, to look at the data, they won't be able to load in an R data file, but they will be able to load in a CSV. So there's some kind of translation that's lost in the sense of translating to other systems for looking at data. There probably actually is a Python package for reading R data. I don't know. But CSV is text, so basically a lot of different programs can read it. But if you just want to work in R and you want the smallest file size as possible, you can just save things as RData. Okay, that's it for today. You are now set up in R and RStudio. You know how to read in data from a CSV file. You know how to do basic manipulations of the data, like accessing columns and computing statistics. And you also know how to write data to a file, both in CSV and RData format. Next up, we're going to dive into more detail into vectors and data frames, along with learning about matrices and lists in R, which are the basic data structures in R. See you next time.